Welcome to video 2.2 in our first Principles of Astrophotography series. In this video, we show that the lines of sight to a deep sky object from two different locations on Earth are effectively parallel to each other. This is something that Ren and I talked about early on. Yeah.
Is this principle true because distances to deep sky objects are large compared with Earth's diameter?
Yes, it is.
And why is this principle important in astrophotography?
Because this principle is key to understanding which celestial objects are visible from your latitude, which is the subject of a future video.
Okay, I'm in.
This video is based on section 2.2 of our first Principles of Astrophotography book, which is linked in the description below.
I'm Ren Edwards.
And I'm Boyd Edwards.
Let's talk sensor sensibility. All right, principle 10, lines to distant objects. For an object that is observed from two different locations, the two lines of sight are effectively parallel if the distance between the observing locations, the baseline, is small compared with the distance to the object.
So this is the same diagram that we had in a previous video, except before it was a single observer looking at two different objects. But now we're going to apply it to the fact that I have a single object that is seen from two different observing locations. So it's like us looking at me looking at the camera and Ren looking at the camera. We're both looking at the same object. So these are two different locations. Location one. And so what this principle says is that for an object that is observed from two different locations, the two lines of sight are effectively parallel if the distance between the observing locations is small compared with the distance to the object. So if we use the arc length formula, as we did before, and we call the distance between these two observing locations S, and then R is the distance between those two locations and the object, then we can apply the arc length formula. So to demonstrate this principle, I've got the same figure that we also used before.
The one with two lines and one line?
Yeah, exactly. So this is two lines that are separated by an angle of 1 degree. And but now we're imagining these being two different observing locations and a single object. And if that distance between these two observing locations, which we're calling S, is small compared to R, I think you can see that even with a 1 degree angular distance, that those lines are pretty close to parallel. So now if we do it for the 1 arc minute, then this distance, is the distance between those two ends of those two lines. And would you say those two lines are parallel?
Yeah,
yes, you would. Yeah.
Principle 11, small Earth. Earth's diameter is exceedingly small compared with interstellar distances. So lines of sight from various points on Earth to deep sky objects are effectively parallel.
So I worked out, and we do the details in our paper, work out the mathematical details, but Proxima Centauri is 4.25 light years away. And Earth's diameter is about 6,400 kilometers. So if you work out how much bigger that distance to Proxima Centauri is compared to Earth's diameter, it's about 9 billion. So Proxima Centauri is at a distance that's 9 billion times the Earth's diameter. So in other words, to get all the way out to Proxima Centauri, you'd have to take 9 billion Earths and stack them side by side to get all the way out there. So it's a good distance, right? And so would you conclude that the distance between the two observing locations, so these are the two observing locations, we're looking at the same object. So you're here, this is Ren, this is Boyd, and we're looking at the same object from different sides of the Earth. Would you say that the distance between us is small compared with the distance to the object?
Oh, obviously.
Yeah.
Yeah.
It's just teeny weeny.
So you're saying if you were in Russia and I was in South America,
right,
and we both pointed a laser at Proxima Centauri, that those lines would be effectively parallel.
Effectively parallel.
Okay.
And the distance, the amount by which they're not parallel, we wouldn't even be able to measure because it's so far away that you just can't tell. So in other words, Earth's diameter is small compared to these interstellar distances, and lines of sight, I don't care where you are on the Earth, the lines of sight are always going to be parallel to any stars out there. I mean, we did this example for Proxima Centauri, which is the nearest star.
Other than the sun.
Other than the sun, thank you for that.
Yeah.
But a lot of the objects we look at are 10 million light years away instead of 4 light years away.
Right, many times.
So the lines are even closer to parallel.
Yeah.
So thanks for watching.
And we'll see you next time.